Okay, last two things, which is the whole calculating means and looking at tables and stuff like that. And the last one is the link between wavelength and frequency, which is pretty hard. But then we're done for the video. You can show me the beautiful revision resource you've made, and you can also do the exam questions. Okay, so we're looking at these numbers. We've got whatever our independent variable is, and we've got whatever we measured it in. So this could maybe be, I don't know, distance in centimetres or something. Dependent variable is what we're measuring, and we always do at least 3 tests of it. And we're going to calculate a mean. Now, calculating the mean is nice and easy. You add everything up together. So we've got 19 plus 21 plus 20 to give us 60. And then we divide that by 3 to give us 20. Yay! We've got an answer. Our mean is 20. Okay? And we can do this for the other ones as well. You can do this along with me. Number 15, we've got 5,926 plus 59 plus 61. Okay, and we're going to divide that by 3. And that gives us 2015.3. Now, do we think that the answer is going to be an average of 2015.3? Maybe not. Maybe there's an itty-bitty problem here. I wonder if you can see the itty-bitty problem. Now, on exams, they're not usually this blatant. Okay, it's really obvious what the problem is. On an exam, it's slightly less obvious. So what we do is we just draw a circle around the wrong one. Okay, draw a nice little circle around it so we know it's wrong. Do we then use it in our calculation? No, we do not. Okay, so instead of doing all 3 of them, we're just going to do 59 plus 61. Okay, 120. We only used 2 results. Okay, so we don't divide it by 3 now because we got rid of one of our results. We've only got 2 results, so we divide it by 2 and we get 60. Okay, and if you do the other averages, you can see that there's a lovely linear relationship. So you can draw the graph with the independent variable on the x-axis. I'm doing all this with one hand. I should be doing it with a ruler and measuring it out nicely. My dependent variable goes on the y-axis. And you always include the units. You do not have to write down the words variable. You should just write down the headings from the table. Okay, so if the table said distance in centimetres, you would write here distance brackets centimetres. Let's do that. Okay, and you wouldn't write down IV on the X. Okay, I'm just doing this as a generic one. You would be doing it for a specific one. Okay, so generic means that I could take this video and I could use it for another 10 classes if I were so, I don't want to say lazy because it's actually working smart, but yeah, I'm doing this generic to show that it doesn't matter what your graph is, you do it the same every time. Okay, and then you would plot on 5 and 20, 10 and 5, 10, 15, 20. We've got 20, 40, 60, 80, and these should all be at the same spaces, so we can do a nice straight line with our ruler through there. Okay, so that's how we do graphs in science. That's really short. We will go through it every single time we've got a graph. Every single time there is a graph, we will go through this. Don't worry, you will get it. If you didn't get it from this, you will get it because we will go over it and over it and over it. And the very, very last one I'm going to do today, this one's a little bit of a tricky one. I know I covered it on my lesson just before the half term, but I want to do it again. And that is the link between the wavelength and the frequency. Okay. Now, I know I spoke about this with the slinky. just before half term, but I wanted to show you it with a diagram. These waves aren't brilliantly drawn. I've just done them by hand very quickly. So for the first one, our wavelength, lambda, is 2 centimetres. For the second one, our wavelength, lambda, is 5 millimetres or half a centimetre. So that means for every one wavelength here, we should have 4 here, because 4 half centimetres makes up 2 centimetres. Okay, now if this was 1 second, okay, because remember hertz, our frequency, is the amount of waves in 1 second. Okay, so I've counted it. We've got 1, 2, 3 waves in 1 second. Okay, and I've counted these as well, and there are 12 waves in 1 second. What's 3 times 4? It's 12. What's 2 centimetres divided by 4? It's half a centimetre. And we can do this with anything, okay? Whatever this... So basically, if you've got a long wavelength, yeah? So in this case, we'd have 3 hertz, and in this case, it would be 12 hertz, okay? So if you have got a longer wavelength, you've got a smaller frequency, okay? Fewer waves go past each second. These waves are bigger. It takes more time for them to move, okay? Imagine if this was a string you were pulling, okay? And to pull, it's 2 centimetres, or I don't know, try pushing a box 2 centimetres, yeah? And then try pushing it half a centimetre. Okay, it's and time yourself to do it. It would take you about a quarter of the time to push that box 2 centimetres as it would do half a centimetre, or push it 2 metres versus half a metre. Okay, so you would expect to see, if the wave is longer, you would get fewer of them travelling past every second. Now, because we can't see the EM spectrum, we can see colour, of course, but we can't actually see these wiggly up and down waves. It's not the easiest thing to get our head around. But hopefully this will show you a longer length means a shorter frequency, and a shorter frequency, so a shorter length means a longer frequency, a larger frequency, okay? I'm not quite sure if there is a better way of explaining this other than showing you this and hoping that it makes some sort of sense. Please, if there are any questions, I am live for your normal lesson time. You can always email me as well. This is a concept that I can grasp, but I'm not quite sure where you're not understanding it, because I'm not in a room talking to you. I'm not getting all the feedback. And maybe you looked at that and go, oh yeah, that makes sense. And you've not needed to listen to me waffle on. Maybe you have listened to me waffle on and thought, oh, okay, yeah, I'm getting that now. Maybe nothing. Please, please, please jump into the live lesson. Ask me. Revision is for filling in gaps in your knowledge. So there's all the objectives I want to go through today anyway. If any of the objectives I have done, okay, you're struggling with, jump in and ask me. Okay, so we've got, these are my revision resources that I've made for you. Okay, you can copy these or you can make your own. I'd love to hear some of the songs that you write or some of the artwork you produce. So I've got a rather boring poster with all the information on, and just something about how to spot an anomaly and the link between wavelength and frequency. So we've got another 2 lessons. So if you've ever wondered about sound and vision, keep going with the revision, and hopefully you all have. Okay, take care. Hopefully I'll see a few of you in the live lesson, even if it's just to say, hello, I'm doing the revision. There are some exam questions as well. Okay, so that's all for now. And yeah, take care, have a go at the exam questions. If there are any questions about either the revision or the exam questions, please let me know. And yeah, hopefully see you soon. Take care. Bye.